One of the issues you are in a domestic situation is you've actually got to be selling money from the grid, you've got to be grid connected, and embedded a generator, or you've got to have some form of storage, really, to make it viable. And really, you've got to look at the loads, and maybe DC loads to make it work. Bless you. One of the interesting things, this is a study actually done in the UK, and this is the production of photovoltaic system over the day, and these are for a particular month, let's say month, it's an August day and it's an August month, actual energy consumptions, okay? And what's this showing is if you were a consumer that was lots of these little dots down here, it's quite possible for the major part of the day to meet all the electricity load of a domestic building from a photovoltaic system. However, if you were the consumer of these dots up here, you have a major problem doing that. This is the theme that will emerge very strongly. Behaviour affects energy use in the building's context. Buildings themselves do not use energy. A car's not moving. They use energy because people are in them, and how the people behave, what they use, how they open and close the doors, how they switch on the lights, what they wear, which determines the heating load, determines the energy load in buildings. Okay? And this gives you an illustration of that, which will be a theme emerging. Critical in terms of realising low energy buildings is the interface between inside and outside. The wall, the facade, the fenestration of the building can collect solar energy, it can preheat ventilation air, it can stop heat escaping. That is the critical element of the building. And it's quite possible to design new buildings in the Irish context which have no built-in energy. You heavily insulated, preheat the ventilation air, you can ventilate the building, you might have photovoltaics to generate electricity, perfectly possible at a technical level. Okay? It may not be viable to do so, and it's certainly not applicable to existing buildings. But in a new build context, perfectly possible to build an autonomous target energy building that doesn't relate to the grid at all. Okay, and there are examples of that. So a particular school building, and here you see photovoltaic panels, water heating, the design of the building to allow lighting, etc., natural ventilation, etc. There are plenty of designs, many designs that incorporate this and have very, very low energy requirements. Okay. And you can look at various technologies. You can do a lot with simple building design, orientation of buildings, where you put the glazing, where you don't put the glazing, where you put things that might preheat ventilation air, or recover warm air from the building. But you can put transparent insulation material on the external fabric of the building. You can glaze it with things like evacuated glazing, technologies that are being developed as we speak, where you'd have a heat loss coefficient of around about half watt per square per Kelvin, compared with low E double glazing, where you'd be looking at 2 watts per square per Kelvin. So you can reduce windows to actually have lower heat loss than the fabric of most buildings today in Ireland. The building fabric, those windows lose less heat than the fabric. If you did some of these things, I don't have time to go through these calculations, if you looked at the 20% penetration of good passive solar design to new build houses, you'd be looking at meeting 8.5% of the built environment target for greenhouse gas emissions for Ireland. So 20% penetration of good passive solar design is only actually going to meet 8.5%, so there's some of these numbers in mind. Talk a little bit about solar water heating. Again, not a new technology, very old. That was a patent. This is one that was installed in California in 1906. Now lots of technologies, lots of designs. Quite capable of converting solar energy into useful energy, about 30% efficiency. Collectors themselves work around 50% efficiency, you've got pipes, you've got the stores, etc. Depending on the area, you can meet a significant amount of the load. And again, you have different collector areas. You've got a liability associated with that. But there is an issue of, you're meeting a certain solar fraction, but for other times of the year you need auxiliary energy to meet that. Solar water heating in the Irish context well designed should meet 40% of the total annual hot water requirement, certainly in the domestic context. Okay, and that will vary with location. These are some maps of what we do across Europe, and these are the number of days for which a solar water heater would solely provide the hot water requirement of the building. No other auxiliary heating required whatsoever. And as you can see, if you're looking at a temperature of 37 degrees C from the solar water heater, 160 days of the year, okay, a solar water heater would provide without any other input in the Irish context. The entire year if you're in Algeria. Okay? In mind, as you raise the temperature, the number of days go down. So 45 degrees C, about 40 days of the year, without any adding, etc., etc. Okay? But interesting enough, if you raise the temperature much further, 45 to 55, it's still 40 days of the year. Okay? So, it doesn't really go down much further. That's quite a high temperature for hot solar water heating. And this is the Irish climate we're talking about. The reason for that is most storage systems collect the diffuse light, cloudy skies, equally well as they collect on something else. Okay, this has meant that solar audits are actually quite popular. This is some things from 2007 of the Green Home Scheme, and back 60% flat rate, according to the 2, quite a large take-up. And the projection is that by 2020, there'll be about 150,000 square metres of solar thermal in Ireland. But given all that lot, it's only going to be at 1.2% of the total of water demand. Okay. There's a whole range of technologies, again, these relate that bigger list you saw earlier on to buildings. Okay? And they do various things. They can simplify the fabric technology, they give you solar gain, they reduce fabric heat loss, or they preheat the ventilation area in some way, or recover heat from it. I will go down through this list. We've got technologies that do some of these things, some technologies that do all of these things. Okay? And again, the selection of them depends on the particular situation, the particular energy needs of the building, etc. But, as I say, the actual savings you'll get, these are real numbers, real occupant measurements of a whole set of technologies in retrofitted into existing buildings, okay? And these are the savings, and these bars around them are the variation due to occupancy. All right? So you can't say that will save you that much, because it will be saving that much or that much. Occupant behaviour, occupant education, incentives and signals that cause the right kind of behaviour are critical to any kind of energy-saving technology in buildings. Right? The building itself does not use energy, it's the people that do. Okay, so these are called rebound effects, user interaction. Social housing can actually be very good, it can lead to higher heating standards and can alleviate fuel poverty. However, in non-social housing context, it does lead to another interesting effect. Let's illustrate by this diagram. This is UK figures again. These are SAT ratings. This is the energy efficiency of buildings. Okay, a whole range of buildings. BOE study, you'll get lots and lots of thousands. Okay? And basically showing that from 1970 to 2001, the SAT ratings improved considerably. Building energy efficiency improved considerably. Building energy consumption remained exactly the same. Okay, why is that? Because the occupants took those gains in terms of lifestyle gains. The occupants are wearing less clothes in the building, they sit down in shorts in the middle of December, whereas previously they wouldn't do so. And that is one of the key things, that energy efficient measures in buildings result in lifestyle gains, which can be very good in social housing in reducing fuel poverty, but in other types of housing actually mean your energy consumption does not go down. And that's actually critically important in terms of the issues. Technical issues are not the problem, it's the societal issues around buildings. So, the challenge is to get that balance between energy efficiency and low carbon energy supply moving forward. It is perfectly technically feasible to have a building that has no grid-based energy at the domestic level in Ireland. The problem is which technology adopt and what signals you give to occupants that cause the right kind of behaviour so that those intervention of those technologies has the desired effect. Thank you very much. Happy to answer questions.